Hello students, today our topic will be chapter 5, Forces and Electricity. Before I go further into the topic, let's watch this video first. So students, after watching the video in the previous slide, I hope you have a better understanding on this topic. Now my first question would be, what is an electric circuit? It is actually a complete path of which the electric current flows, and it should be constructed in an unbroken loop. These are the circuit symbols that you will need to remember throughout our lesson today. For example, battery, bulb, switch, motor, buzzer, and ammeter. Students, on this page, there are 3 pictures of circuit. Now, can you tell me which of these circuits would work? None of the circuit will actually work. Let me explain why. The first, a plastic comb is actually not a conductor of electricity. A plastic toothbrush is of course not a conductor as well. How about the metal screw? Yes, the metal screw is a conductor. But did you notice the power source is missing? So student, what makes an electric circuit complete? It's simple. A simple circuit consists of a battery, a light bulb, and conducting wires. If either one of these is not there in the circuit, then it becomes an incomplete circuit. Now students, please take out a piece of paper and your pencil. I have a question. If you're given a bulb, a wire, and a cell, can you suggest one way to connect them to get the bulb to light up, and another way to connect them such a way that the bulb does not light up? You should use only electrical symbols when you're drawing the circuits. This slide shows you the sample answer of completing the circuit, the question given in the previous slide. Students, do you know electric circuits play a crucial role in our daily lives? For example, I'm sure many of you use hairdryer, and we all use lights at home. Besides that, our refrigerator works on electric circuits. Hello students and welcome back. Now, have you heard of the word parallel circuit and series circuit? So students, you should be able to differentiate the series and parallel circuits, as well as compare the brightness of lamps in series and parallel circuit. So students, in a series circuit, all components are connected in a single path. There is only one path for the electricity to flow, and if there is any break in any part of the circuit, it will open the circuit. The lamps share the electricity from the cell equally. Now students, Please put on your thinking caps. Do you think the lights at your homes are connected in series or parallel? How can you tell this? Students, look at the picture in this slide clearly. For series circuit, if any of the lamp burns out, none of the other lamps will work. So for series circuit, there are two main key points that you should remember. Current is the same all the way around the circuit, and the voltage is shared among the components. However, in this slide, you will notice in a parallel circuit, the components are connected in separate paths. Electricity flows through each path separately. So a break in one of the paths will not open the circuit, and the same amount of electricity from the cell passes through each lamp. For parallel circuit, even if one lamp burns out, the rest of the lamps will stay alight. Look at the picture. The bridges are connected in parallel. In simple words, if either one of the bridge falls off, the cartoon character can still cross the bridge using the other bridge. So the main two key points of a parallel circuit that you need to remember is each pathway receives the full circuit voltage and the current is shared between the components. Now students, please put on your thinking caps. I have a few questions. My first question would be, what happens to the lights in a series circuit if one of the lights goes off? So, what kind of circuit has more than one path for the current? Now, what happens if one light burns out in a parallel circuit? Before I end the lesson, I would like to share something with you. At home, usually the electrical wiring is made with copper instead of aluminium. Why? Because copper wires are safer choices compared to aluminium wires. They are more reliable and they have stable connections. And they are durable as well as corrosion resistant in comparative to aluminium wires.